Welcome to a special episode here on the GCN Tech channel because I'm joined by a legend in the world of bearings, or he certainly is for me, and I reckon by the end of this episode he's going to be a legend for you too. Welcome, Hambini.
Thanks very much for the introduction. I think it might have been a bit over the top, but I'll give him my best shot.
Cool. Okay, so Hambini himself is actually an engineer by trade, so he's certainly slightly more qualified than myself to talk about bearings this size. And well, you submitted your questions for us to answer, so we're going to do just that. Now, one of the most common questions we get actually is, what's the difference then between a low-end bearing and a high-end bearing in terms of drag or resistance when riding along? And I'm pretty keen to know this because I love a marginal gain here and there. Yeah. So hit me with the stats.
Okay, so if you get a bearing that's typically no name versus something that's named and isn't a fake, the typical drag for everything, so that's your bottom bracket, freewheel, the hubs and the jockey wheels, is about somewhere between 7 and 10 watts.
Okay, so it all adds up, doesn't it?
It does. The vast majority of the drag comes from the seal. It's nothing to do with the bearing material, whether you buy ceramic or steel. It's almost irrelevant. The vast majority comes from the seal, and if it's contacting. The next proportion of the drag is from the lubricant you use. So if you use like a thin oil, which is less viscous, you'll have less drag. The problem with doing that is you'll have to maintain it more frequently. Some of the top cyclists, I think it was Alberto Contador, he used to take all the seals off and put in a drop of mineral oil. That's what his mechanic used to do to reduce the drag to the absolute bare minimum.
What's the difference between a cartridge bearing, which is what these types of bearings are commonly known as in the bike world, up against a cup and cone style bearing? Now, a cup and cone style bearing is what, traditionally in the bike trade we used to use for, forever until the invention of these bad boys.
Yeah, so a cup and cone bearing is in effect an angular contact bearing that is constrained. So an angular contact bearing that we've sliced in half.
That's so cool.
Is one of these.
Yeah.
What we've done is I've tried to draw pretty poorly, a section through it, and that's what you see here. At the same time, this type, which is what's commonly known as a cartridge bearing, again, I've drawn a section through here, and I'll describe what the difference is. The first obvious one is, when you look at that one, it's symmetrical through the axis, so you can go both ways, looks the same. This one, the angular contact, is not. So one side is the cup, which is this side.
Yeah. That's better, isn't it?
So the cup is the inner race.
Yep.
And the cone is the outer race. Now, unfortunately, in order to do this little prop, I had to weld in there. So that small bit of metal shouldn't be there. So if you show them that piece,
yeah, you
can see the shape is not symmetrical. What happens is, on the cartridge bearing, because it's symmetrical, it takes load in either direction, so you can run it in either way. And a lot of manufacturers use that ability. So notably SRAM with its GXP bottom bracket. Okay. One bearing is fixed and it takes load both ways. Whether you're pedaling with your right foot or your left foot, all the axial load is going through the non-drive side bearing.
Okay.
The turning load, which is called a radial load, is being transferred on both, but the axial is just on one side. When you look at the angular contact bearing, the ball for the same outside diameter is bigger. And the angle, the contact angle, which is called the alpha angle, which is this angle here. Some bearing manufacturers put that angle slightly differently, but I've drawn it like this for consistency, is much further towards an axial direction than the cartridge bearing. The cartridge bearing is designed to take radial load and not much axial. The angular contact will take a lot of axial, so this is called the load center, where the two lines cross. So if you had the bottom half of the bearing and drew it across, you would have a load center. It would be offset by X millimeters, maybe 20 or 30. So the axial load carrying capability is significantly more. The original question was, well, what's the difference between a cup and a cone? A cup and cone is an angular contact bearing, it's just unconstrained. So a cup and cone doesn't have the metal cage holding the balls in place, whereas the true angular contact does.
How do you know what size bearing you need for those DIY replacements at home?
Okay, so the best way to do it is to take it out and measure it. If you can't do that and you've just got the numbers on the outside to go off, you can decipher the bearings. Once again, easiest job is to go into Google and just type the number in and it'll give you it. But for interest's sake, I'll go through it on this board. The first number on a 4-digit bearing will typically be a 6 or a 7. A 6 is a deep groove ball bearing. 7 is angular contact. The second number is in effect the outside diameter of the bearing, and it doesn't follow any particular coding. So it just goes from 7, 8, 9, 0, 1, 2, so on, and that's just getting bigger. The 06 is the ball. So balls will go 00, which is 10 mil, 01, which is 12, 02 is 15, 03 is 17, 04 is 20. When you get to 04, all of the subsequent numbers you just multiply by 5. So 05 is 25 and 06 is 30. So from this, the BB30 bearing is 6, which is deep groove ball bearing. The 8 is just the second number in the outside diameter series, and it's a 30 mil bore. So it's 30 by 42 by 7.
This is like something off of Countdown, because you've gone through that so fast. All I'm thinking is, that 8, it doesn't really make any sense, but I'm not going to worry about that, because I think for most people out there, they're not really going to look into that in too much detail, are you? So if you can, look at the side of the bearing on there for those numbers, basically, and that's what you're going to be looking for. How do you tell when a bearing is worn, and when is the best time to replace it if you can't tell? I mean, from my own experience or knowledge about bearings at least, if you were to cut it away like this, you can see when you're turning it that different components or different parts of the bearing are moving at different speeds, which I guess means they're wearing at a different rate.
Yeah, so as John's turning the inner race, so this bit, which obviously it's not a complete bearing, as the speed that rotates at is called the inner race frequency. So if you were to take a bottom bracket example, typically some people are going to pedal it, to make the numbers easy, let's say 60 RPM. The reason I picked 60 is because it's a minute. So in a minute, you're going to go 60 times. The inner race travels at a certain speed and gives you a frequency. The balls, so these things, will turn at a certain frequency. The whole thing is turning on the fundamental train frequency. So the fundamental train frequency is the rate that effectively the cage is going round at. The cage rate is slower than the inner race. And you've also got ball spin frequencies on the inner race and ball spin frequencies on the outer race. So there's quite a lot of frequencies in there. Inevitably, the failure mode on a bicycle bearing is usually from an external factor such as contamination. So you get a bit of grit in there, the ball spins round and then grinds itself into one of the races. So that's how that fails.
If you are going to re-grease your bearings, what sort of grease should you use? And how much? Because certainly when I used to re-grease cup and cone bearings, so headsets, that sort of thing, I would pack as much grease in there as possible, probably to make the job a little bit easier of loading all those bearings in and making sure they didn't fall out around onto my mum's best carpet or something like that, which I got in trouble for. Any tips or advice there? Yeah,
so bearing manufacturers, the big ones, so NTN, SKF, those people, they'll give you guidance as to how much grease to put in. Typically, it's a third, so the third of the total volume.
Okay.
Should be grease.
Yeah. So you're going to put. So say this bearing here, I've gone ahead, I've degreased it, dried it out, because I always use some air, blast out with air, or I've even used a hairdryer before now, just to get it perfectly dry. Hopefully that's all right to do. Is
Yeah,
it?
that's fine, yeah.
Okay, good. I'm not going to get told off for that one. So I should go, say, a third of the way around. Should then just spin it just to get it in there a little bit more?
No,
or
it's a third of the total volume.
Okay, right.
Yeah, so you don't necessarily need to go a third of the clock face.
Yeah.
Just a third of the total volume. It's to spread it out evenly, but just a third. If you overfill it, what'll happen is the balls won't be able to move very well, so you'll have more friction.
Okay.
The aim of the grease is, as the thing warms up, it actually turns to oil.
Yeah.
So it goes soft, becomes more of a lubricant, and that's what you're rolling in.
What sort of grease am I going to put in there?
General guidance is lithium grease, and it is based on a scale, the grease type of NLGI, and something like a 1 on that scale would be the one to go for.
Okay, it doesn't really mean a lot to me, but I guess if you're really into it, you can have a little look and research.
Have a look at a data sheet, it'll tell you.
Okay, now I have to say, you mentioned earlier on about when the grease turns into a liquid, when it gets up to a certain temperature, that sort of thing. I recall, I think it was either Fabian Cancellara or Alberto Contador, or who we already have spoken about and remove seals on bearings, that kind of thing. I have this weird feeling that one of them had a guy at the side of the mechanics truck who used to spin wheels before he raced in time trials to get that lubricant turning into a liquid, essentially. So getting the grease into a liquid. Is that going to give you, do you reckon, hypothetically speaking, significantly better or less rolling resistance in the bearing or not? It's going to be so marginal, isn't it?
For the first few kilometres, probably.
Yeah.
I mean, the thing is, at their level, the difference between winning and losing is that sort of attention to detail.
Yeah.
If you're just out smashing it on the weekends, then it doesn't matter.
Yeah, we're not going to be like Formula One pits, are we, really? Where they warm up the tyres. I can't imagine you sat in your garage, me sat in mine before we go out, spinning our wheels to make sure that the bearings are... No. Or maybe you do.
No, I don't.
No, okay, that's good.
I don't even wash my bike.
Right, another cracker of a question here. Andrew Montgomery, do ceramic bearings last forever?
The thing with ceramic bearings on a bike is they are technically, well, the vast majority of them are hybrid. So the balls in them are silicon nitride or something along those lines, so a very hard material, but the races aren't, so they just generally tend to be steel. If you have a very hard material rubbing against a relatively soft material, what happens is it wears a track inside the bearing. So while the balls don't fail, the track that it develops does. It would be akin to getting a locomotive and running on a road. The rails are significantly harder than tarmac.
Yeah.
So it would cut a hole in it. What you want is materials that have a hardness that's much nearer to each other, and they will last longer.
Okay, so that's the thing. Like, a lot of people out there, and I've fallen victim to this in the past, you see a ceramic bearing offered really, really cheaply.
Yeah.
And you think, oh, I'll be like that, that's like £2 or something crazy low price. Ultimately, that is not going to last, is it?
No.
I think we can safely say that.
Yeah. There's a couple of things with bearings as a whole, not just specifically ceramic. One is fakes. So there are a lot of fake bearings on the market. You wouldn't believe how much that have crossed my desk and the desks of my colleagues. So in that sort of size, okay? So we're not talking small bearings.
That's baffled me really, because I've never seen a bearing this size. Well, I probably have, but in the back of some big machine or something like that in a factory. And I wouldn't have thought that someone would be making fakes for that. I would have thought, because I'm, I suppose, obsessed with bikes, I would have thought, they only make fake bearings for bikes, but yeah.
The fake bearing for a bike is probably only going to cost £2, $3, €4, whatever the currency is. But one of these bearings costs a lot. Yeah. So if you can fake one of these, the margin that they get is significantly greater. In terms of the bike, when you buy the fake bearing, what you're getting is a bearing that doesn't have the dimensional accuracy. What they rely on is people not having the instrumentation and the measuring gear to be able to tell that the bearing is not quite right.
Yeah. Now, one of the most common questions actually you see on the internet is someone who says, I've had a bottom bracket for 2,000 kilometers and it's already worn out. And then someone else will have exactly the same bottom bracket and they'll say, well, I've been riding for 5 years with that bottom bracket and it's still in perfect condition. We've got a graph. What's this graph all about?
So one of the things that you have in engineering principles is load versus life, and that's typically called an SN curve, but I've simplified it here for the benefit of the viewers.
And me.
So load is along the y-axis and cycles is along the x-axis. The x-axis is a logarithmic axis, so it's going up in multiples of 10. It's not linear 10, so we've got 10, 100, 1,000, 10,000 and so on. If you are pedaling with a very, very low cadence but massive torque, you're putting a lot of load into those bottom bracket bearings. So you'd be over here. So you would actually get less life than someone who spun the cranks up and was putting less load but more RPM through. The limiting factor on a bike is not the speed, because it's whether it's 60 RPM or 100 RPM, that's nowhere near the limit of the bearing, but the torque that you put through the bearing is. So that's what that differential is. So the person who is only getting 2,000 kilometers, if they are on the heavy side, then they'll be that way.
Yeah.
The person who's lightweight and spinning at 120, they're putting significantly less torque through it, so they'll get more cycles, and that's just the way it is.
Yeah, so you got like a track sprinter, they're going to be somewhere around here, aren't they?
Yeah.
And then your climber, your real lightweight rider, they're going to be, well, hopefully if they're spinning away, they're going to be somewhere, hopefully down there, aren't they? I guess. Yeah. Now finally then, what about maintenance of bearings? Because not everyone likes to get their hands dirty and grubby like us in the workshop, do they? What can the viewers do to try and get longer life basically out of their bearings?
There's a few things. The biggest one is contamination. Contamination will make the life of the bearing shorter. That's right. The biggest one. The other one is when you come to install it. When you install bearings, you tend to have a press that presses directly onto the bearing, like a BB30 press or something like that. One thing that people sort of aspire to because they think it's good is having stainless steel presses. Stainless steel is a pretty terrible material in some characteristics. It has this characteristic called it galls.
Right.
And that's when it sort of friction welds itself to another material, or friction welds itself. And you can have an issue where you put the bearing in, and as you're tightening the press, it galls on the surface, so it's trashing your bearing before you even get started.
Yeah.
So I'd recommend you use either plastic or aluminium, or if you are going to use stainless steel, make sure it's got a bigger clearance than you would normally have.
Okay.
Another thing is when you're putting the bearings in, the most common failure mode that I've seen is poor alignment. Okay. So alignment specifically in bottom brackets, because unlike wheels, which tend to be machined on a lathe, bottom brackets quite a lot of the time on carbon bike frames are glued together in the middle. So what happens is you've got two bearings and they're slightly misaligned. So if you take these two as an example, you might have what's known as parallel misalignment. So if the right hand is the drive side of the bike and the left hand side is the non-drive side, that's parallel misalignment, so they're completely offset. Or you can have angular misalignment, so the center lines are in the same place and one's tipped.
Right.
If you have any of those things, and you've got moving parts in there, then what the crank tries to do is it tries to straighten itself. It can only straighten itself through the bearings because that's the only point of motion, and you'll tend to do that, which is fretting. Bearing is really, really hard. Carbon isn't, and it'll just wear the hole out.
Oh, right.
So you need to worry about that.
Yeah.
In terms of routine maintenance, I personally don't take the seals off to repack with grease. Right. I just change the bearing.
Yeah, because you think the life's gone, basically.
Life's gone, yeah. But plenty of people take the seals off to grease them. I certainly wouldn't recommend knocking them out.
Guilty. Now, a massive thanks to Hambini today for popping in and telling us all about bearings and all sorts of graphs and stuff like that. I mean, I've learned a hell of a lot today and I hope you have too. And after all, if he wasn't here, I wouldn't have had some of these. And how cool is that? Now remember as well to like and share this video, give it a big thumbs up, tell your friends about it, especially if they've got bearings that are absolutely knackered and you need to just reaffirm the point they've got to replace them. And also remember to check out the GCN shop at shop.globalcyclingnetwork.com. We have a whole heap of products for you to check out. And what video should they watch now?
I think maybe they should watch you pressing in a bottom bracket.
Hopefully I did that one right. No, I'm pretty sure I did. And it's going to be just here.